All right, let's move on to section 13.5. And in 13.5, we're going to learn how do you use the law of sines to solve triangles. Okay, so remember, solving a triangle means finding out all the missing parts of the triangle. Okay, so previous lessons we solved right triangles. In this lesson, we're going to look at non-right triangles. If we don't have a right triangles, we can't use the standard trig ratios. We have to use something else. So the law of sines is one that we can use. Okay, now let's first look at where the law of sines comes from. So I have a triangle here, just labeled. So I'm going to drop a line down here, perpendicular to the base. I'm going to call it H, that's the height. Okay, so if I look at A as my reference angle and use the sine ratio, the sine of A would equal opposite over hypotenuse, would be H over C. If I look at this triangle over here, I can say the sine of angle C is equal to H over A. If I solve both of these triangles for H, this one's going to give me H equals C times the sine of A. And this is going to be H equals A times the sine of C. Now if I do substitution, if they're both equal to H, I can set these equal to each other. So C times the sine of A is equal to A times the sine of C. Now if I divide both sides by the sine of A and get this, so I'm going to get C equals A times the sine of C over the sine of A. Then I can divide both sides by the sine of C and bring that over here. So it's going to be C over sine of C equals A over the sine, right, sine of A. So this is part of the law of sines. If you look in your book on page 882, you can see the whole law of sines. It looks like this, and they actually have these flipped over, which is the same thing. You can use the reciprocals here, but the sine of A over A equals the sine of B over B equals sine of C over C. Okay, so we just derive part of it so you can see where it comes from. This is equal to these two parts of it, of the law of sines. So you only use the parts that you have, what's given to you, to find the rest of the missing parts. Okay, so let's apply it. So the law of sines doesn't work in every case. So the case means what parts of the triangle do I know? Do I know two angles and then the side, or do I know an angle, a side, and an angle? So the side's in the middle of the two angles versus a side that's not in the middle. Actually, these cases don't really matter because they're basically the same thing. Because if I know two angles in a triangle, I right away know the third because it adds up to 180. So the first thing we're always going to do is draw the triangle. And it doesn't really matter how I label it as long as I am consistent with where the sides are. So let's just go A, B, C like that. So if this is C, the side C has to be opposite it. That's the only thing that matters. Okay, so now we label the parts we know. Angle B is 34 degrees. Angle C is 100. Side B is 8. Okay, so the three things I need to know is angle A, side C. So angle A would be the easiest thing to find because it has to add up to 180. Okay, so angle A is going to equal 180 minus 100 minus 34. So it would be 46 degrees. Okay, so that's going to be 46 degrees. Let's find side C next. So we use the law of sines. So the sine of 100 over C is equal to the sine of 34 over 8, because I know those. Okay, so now I solve for C, just cross multiply. 8 times the sine of 100 equals C times the sine of 34. Divide both sides by the sine of 34. So that's going to cancel. So C is going to equal this right here, which I'll plug into my calculator right now. And if you have your graphing calculator, you can actually plug this all in at once. So 8 sine 100 parentheses divided by the sine 34. And it looks like I get 14.1. Okay, so that's C. Okay, so the last part I need is A, so I can do law of sines again. Sine of 46 over A equals, now I can use either these, the ratio of C over C or B over B, it doesn't really matter, but I'm going to use B. The reason I'm going to use B is because that was given to me, so I know those are the correct answers, whereas C I solved for. So if I made a mistake somewhere in C, it's going to reflect, I'm not going to get the right answer for A then. So let's cross multiply. So A is going to equal 8 times the sine of 46 over sine of 34. I kind of skipped a step there, but you can see how that works. When I multiply here, I'm going to get 8 times the sine of 34. I'm going to have to divide that. So using my calculator, see what we get. 8 sine 46 by sine 34. 10.3. Okay, so that's A. Now it's important that you go back and look at your triangle. Does it make sense? The biggest angle and the biggest side should be opposite each other. The smallest angle and the smallest side should be opposite each other. So we're in good shape there. Okay, so we can directly use the law of sines if we have two angles that we know for sure. Okay, now when we have side-side angle, two sides and an angle that's not in between, then we've got some issues. We've got several possibilities. We could have, with the given information, a triangle that's not possible. We could have one triangle that works for the data that's given, or we could actually have two possible triangles. Okay, so in your book on page 883 kind of shows the different possibilities here. And you can see it right here. So the first thing you look at is if the given angle is obtuse, then we could either have no triangle if the opposite side is shorter than the other given side. You can see why here. Okay, because the opposite side has to be the longest side. Okay, so there could be a not possible situation, or you could have a triangle that works. You could just use the law of sines. Okay. If angle A is acute, less than 90 degrees, then we have a few possibilities. You can see them all here. So one possibility is you could have no triangle possible. So angle A is locked in. We know side B and we know side A, side-side angle. Okay, and then we draw a height here. So if the height straight down from the end of B is longer than A, then you can't make a triangle. Okay, if it's equal distance to A, then you can make one right triangle. If A is longer than the height, well then there's two possibilities. You could either have two triangles, as you can see right here. We can swing A so that it could create two different triangles. This little skinny triangle with an obtuse angle here, or the bigger triangle with an acute angle here. That's where it gets complicated. Okay, or if it's too long to create two triangles, you just have one triangle with an obtuse angle here. Okay, so we're going to go through each possibility here, and what I like to do is just assume I'm going to have two solutions. Okay, and then what's going to happen is you'll find out that the second solution ends up being not possible, or it actually works out. Okay, so let's do the first one here. Oops. Angle A equals 115 degrees. Side A equals 20, side B equals 11. Okay, so let's draw this triangle. So angle A is 115, side A is 20, side B is 11. Okay, so obviously it's not drawn right because this is supposed to be an obtuse angle and it's not, but the picture doesn't really matter. So we're going to go through and use the law of sines to find the missing parts here, and we're going to assume we'll see what happens. Okay, so looking at this, one thing you can see is that this has to be the biggest side because it's the biggest angle that's across from it, and it looks okay so far. So what I need to do is find angle B. So I go sine of B over 11 equals sine of 115 over 20. Multiply both sides by 11. I get that. So I got to calculate that. And I had 0.498. Probably should go to 3 decimal spots. So now to calculate angle B, I do inverse sine. So second sine of 0.498. And it gives me 29.9. Okay. So angle B is 29.9. So from there I can find angle C because it has to add up to 180. So we're going 180 minus 115 minus 29.9 gives me 35.1. So I've got that side. And finally, I can find side C. Well, side C, I can use the law of sines with. So sine of 35.1 over C equals sine of 115 over 20. Okay, so we can cross multiply and solve that part of it. So C is going to be equal to 20 sine of 35.1 over sine of 115. .7. 12.7. So that one is done. Okay, so I got another one. Okay. Okay, so let's draw this one out. So A 3.5, angle A is 51, side B is 5. We don't know C. Okay, so looking at that, I'm probably going to use law of sines to find angle B. Sine of 51 over 3.5. So we'll go sine of B equals 5 sine of 51 over 3.5. 5 1.11. Oops. So I got to go inverse sine of that. Second sine 1, and I get an error. So immediately if you get an error like that, guess what? And this makes sense because I can't have a sine greater than 1. Think about a unit circle. So that's not possible. Oops, not possible. So we cannot make a triangle with this given dimensions. Okay? Alright, finally the next one. Okay, so run out of time here possibly. So A is 40 degrees, side A equals 13, side B equals 16, and C we don't know. So again, we're trying to find angle B. Sine of B over 16 equals sine of A over 13. And A is 40, so plug in 40. Okay, so quickly we'll calculate that. I'm actually going to see if I can do the whole thing. Inverse sine of 16 times sine of 40 divided by 13, 52.3 degrees. Okay, so that's angle B. Okay, angle C is going to then be 180 minus those. So it's going to be 87.7 degrees. Okay, and then we can find side A after that. So just to save a little time, I'm not going to solve for side A. Now the problem here is that there's a second triangle that's possible here. Okay, and the reason is because when I found this angle here, there's a second angle that gives me a sine value that's the same. Okay, so let's see here. This was actually 0.79. So angle B was 52.3, but this was 0.79. Okay. There's another angle, an obtuse angle, that actually gives me the same thing. Okay, so what I do then is I reflect that. Think about the unit circle. This is 52.3. If I reflect it over here, I can find what that angle is. 180 minus 52.3, and I get 127.7. So I can create a second triangle with an angle B that's 127.7 and solve that triangle too, and it's going to create two triangles. Okay, so what we'll do in class is we're going to do a couple more examples of this because I don't have enough time to finish this example or do any more examples. So we'll do a couple more examples of this, and then we'll look at how do you find the area of a triangle using the law of sines using these formulas. So this is also in your book. So we'll cover that in class.